is Nigel Watts, and I am the Managing Director of Proto Software, responsible for the Asia Pacific region. Today I'm actually calling you from sunny Kuala Lumpur, although looking out across the skyline at present there's a few storm clouds brewing. But it's a wonderful day to be able to present to you all here. I am involved with a team of engineers and developers across the world who are pulling together this fantastic ProtaStructure platform, and today I've got the privilege of being able to take you through what we've been up to with development, so you can get an idea of some of the recent innovations that we've been making with this software technology. And what I'm going to do to start is just to actually give you some insight into our business. I think it's an interesting organisation that we are part of. The Proto Group is actually part of a bigger group of businesses that specialise in consultancy and engineering with a professional approach to design. So a little bit about the Proto Group. We are a very large consulting practice based in Turkey. We have about 350 consulting engineers and architects within our group, and we do a range of interesting projects around the world. Recently, we've actually had the privilege of working on the new Istanbul International Airport, which you may have just heard has been recently opened. In fact, they moved the entire airport from the old airport in Istanbul over to the new one in just a day. But it is the largest terminal building in the world, and it was a fantastic job to be involved with. We were the structural consultants on that project. We've also done a lot of large infrastructural projects, many metro stations around not just Turkey but across Europe. In fact, we've worked in about 30 countries around the world and delivering some very unique and challenging projects. The Proto Group also has a lot of expertise in earthquake engineering and BIM design, and these are things that have been implemented on many of the jobs that we were involved with. We do resell and distribute Autodesk products. Now, Autodesk, as you will be aware, is a large player in the architectural engineering and construction market, and we have a good insight into how their technology is evolving, particularly in relation to BIM. We also have obviously been developing software for many years, and that started in the early days with a product called PB Orion, and that's evolved now into the ProtaStructure software suite, which is delivered by over 40 professional developers around the world. As a business, we've been growing and we've been investing to move into new markets. Headquartered in Ankara in Turkey, but we're also starting to expand our presence. And in Asia, where I'm based, we have a team of 15 people here, and we also have regional partners across Asia where we're delivering solutions into. So Vietnam, Cambodia, Hong Kong, Indonesia, Thailand, India. We also have other satellite offices, and we're also starting to expand our reach to other parts of the world. So for those of you who are perhaps in Africa or in America, you will be able to be serviced directly from us or one of our dedicated distributors. Now today I'm going to take you through this brand new release of ProtaStructure 2019. Just before I start that, a little bit about this platform. ProtaStructure is really a structural BIM solution for concrete and steel building design. We work with physical objects to quickly create models, and then we automate the design of those to a wide range of different codes of practice. From the design, we then produce all the documentation automatically, so that goes from drawings down to calculation documentation, right through to producing BIM models that can be communicated with other platforms, including Revit and other programs that are involved with delivering BIM projects. Our users like the platform, and often we get comments on that they're very easy to use. But our key aim with the software is to help you become more productive and more profitable in how you deliver your projects, whilst retaining quality and professionalism at each stage. So enough of talking about this. Let's get into it, and I'm going to show you how this works. So I'm going to come in and launch ProtaStructure 2019. And today I'm going to take you through a little bit about the software. So for those people who are new to ProtaStructure, you'll get a feel for what we do within the platform. But I'm also going to touch on some of the new functionality that we've introduced with this release. Now, if you're new to the platform, there's quick start guides. We've got a lot of YouTube type video content available that you can watch now. We regularly update the software and they're all delivered live. When you start the platform, you can start in a number of ways. Now, I'm going to just create a project here, and we might just call this Proto Global 1, and I can hit OK. And when we do start, we've studied different markets around the world, and we understand how you go about delivering projects in each of these markets. So the way you might design and detail a project in Indonesia may be quite different from the way you approach a project in the UK. So we've developed different templates here that you can load, and these will follow typical design and detailing settings for each of these territories. Now I'm just going to pick on a template here. I might this time around use the Philippines template. They use the American codes. They have their own national code of practice 2015, which is very similar to the UBC code. So I'm going to import this, and what this then does is it sets up the project to suit the way that an engineer in those territories would deliver work. And when you move into the Prota modeling environment, you can start in different ways. Now, if you have an architectural drawing, you can import this. If you have a model, physical model from Revit, you can bring that straight in. You may even have a big project where you're having to build it very quickly and you want a few engineers to work on the job, and you can break the model into components, maybe a podium and a tower, and these can be combined to speed up the modeling process. What I'm going to do with this project is I'm just going to start something simple from scratch to give you an idea how you can quickly build and create models here. So I'm just keying in some basic grid lines here, and we can hit OK, and then an arrangement can be created here. Now these are dynamic. You can make changes as you go. So if I decide that these grid lines here, maybe instead of a straight grid line here, maybe I'd like to create something that's a bit different. Perhaps it's curved or a different shape. These can be done. If you have grid lines which are unusual and set out, we see a lot of buildings these days which are not particularly regular. Maybe you've got a funny facade, okay, that the architect has come up with, and you want to create that, then you can use these grid lines to set out whatever type of unusual geometry that you might want to create. Once you're happy with this, if you just right click, you can create that geometry. And all the modeling is dynamic, and I can just work my way from left to right here. I'm going to start by placing some columns here. I can box around to place columns quickly. If I have columns which are perhaps orientated a little bit differently, these can be set out, okay? And maybe I'd like to just place those along the curvature of that grid. They can easily be defined. Now we have libraries which will cover other types of profiles, common profiles that you might want to regularly use in buildings. They can be concrete, steel, different libraries here are set up that you can draw from. Maybe you've got built-up sections. Perhaps you have cold form sections, and you can use a database, or you can create your own custom form sections. You can even develop composite sections where you have maybe steel encased in concrete. So in here, I can just maybe come in here. I might want to use, say, a circular column. I can key the properties in. Underlying this, we calculate all the engineering properties for you, but then you can then just grab this and start to use it within your model. So I can just box around here, and we can quickly create the objects in the model. I'm going to place some walls here, so again I can just click to insert these quickly. Okay, maybe at the same time I also want to create some beams. So again we can just use this to box around. I can feed the properties in, and then they can be created here. Okay, so I might create those curved beams. If you're coming in, if I want to just snap to points there, I can come in here. Maybe this beam's going to crank and follow the curvature of that grid. Maybe I'd like to actually come in and create a curved beam. So all this is dynamic, and you can create this as you go. If I have a lot of beams in a certain area, I don't have to go and click them one by one. I can just box around and they'll be created. We don't have to worry about overlapping. We understand that physical objects exist here, and when I pull these beams through, it's just putting the 2 extra beams at each end. Now for secondary members, you can just handily snap to points to quickly create them. If I want to put in beams at quarter point, third point, mid span, I can snap to these points. If I hit F2, I can type a particular distance in, and we'll pick up the exact locations there and other handy points. Now you can use your cursor keys just to move things around if you just want to adjust things quickly against, say, the architectural drawing. That can be done. Maybe if I come down here, perhaps these columns at the moment, they might be sticking out the side of the building and I just want to reposition them. It's easy just to create this. You may even have situations where perhaps I want to fix the position of a beam. So we can use anchors here to do that. Later on, if you decide that in the project that you might want to make a change here, perhaps the beam width has to increase, that anchor positions that beam in place and you can make adjustments. So that's very useful if you're just wanting to set things in place. Now, before I put my slabs in, we actually have what we call load libraries here. Now, we can use these to help develop finishes on a building very quickly. If I've got, say, a bedroom and maybe I've got a bathroom, and I want to very quickly develop the way in which these are loaded, I can come in here and choose different colours to represent things. For, say, the bedroom, I'd like to key in the finishes. Maybe I have a screed on top of the floor. On top of this, maybe I have maybe a parquet floor. I can key in the properties here, and the self weight of this is automatically calculated for us. Now we can have libraries of different finishes that we might want to typically use for both slabs and walls, and we can build up these loads. If I go to the maybe the bathroom, the screed thickness might be a little bit thicker. Perhaps on top of this I've got a marble flooring. Again, we can define these and that self weight's calculated. Now the advantage with this approach is that later on, if the architect changes his mind, which often happens, you can just come in and edit this. Everything within the building can update. You don't have to go and individually tackle changing 500 slabs if these are changed his mind. So when we come to define slabs, we can just come in and choose from the finishes here. So I'm going to grab, say, the bedroom. If I'm not sure about the live loading, this just links to the code, and we can just come and choose those values, and then we can place our slabs in the building. Okay. I may have maybe my bathroom. Maybe in this situation, I just want to key the live load in. I can easily do that. So we can just run around and just create that. Of course, you can key any of your own finished values in as well. We're not constraining you. It's entirely up to you what values you would like to use here. So I can just run around here, the edge here, and we can place those elements within the model. Now, what you may notice here is that we've automatically worked out the yield line here. If we right-click on a member and you come to edit member loads, you can see the distribution of dead and live load. All this is being automated for you. You don't need to worry about calculating this yourself. If you do want to use other distributions, maybe you want to mesh the slab and use a finite element distribution here, you can. This very accurately transfers the weight from the slab to the frame members for you. Now, if you have other shapes, so maybe I've got an unusual balcony, maybe the architect wants to define something, again, a bit freeform, we can use sketch lines to help create these. Okay, we can then come in and use those. Maybe I want to grab the properties of that slab and I want to put a slab in, maybe it's 150 thick and I'd like to drop it 100. Okay, we can just come in here and take advantage of that to define that unusual shape. Now, before we get too far on this project, and you might just see that this is starting to look like a key plan, we can start to interrogate things. So I'm going to look here. I maybe want to look at what column sections I've used in my model. Maybe I want to check what beam sizes I have, and you can see I've used a couple of beams so far. My slab thicknesses, again, we can just review this. I may also want to look at the loading that I've applied. So my superimposed dead load, my live load, all this we can interrogate before we get too far on the project. Okay. So if I just like to quickly review things before I get too far on, that's easily done. Now I'm just going to touch on a few of the more advanced things that we have in here, just to give you an idea of the flexibility that the system has. So I'm going to move into my columns here. I've actually maybe have traditionally just used a standard shape here, but maybe the architect's got something a bit more challenging, and I want to create a different type of column section. I can come and sketch this out. Okay. In the software now, we can automatically contain these types of shapes, and it will propose to you an arrangement of bars. All these you can work with. So if I decide that maybe for this column shape, I actually want to create some additional containment steel, I want to use this as a template for my design, I can run around here and just come in and create. So if I wanted to add some extra bars here, okay, around the perimeter there, maybe I've got some perimeter bars I want to add in, okay. We can take advantage of driving containment for any shape column we like, and we can then use this as a template for the design and detailing. So if I hit OK, that's then set up. We can then use that for design. Now, we can also do the same thing with the walls. In fact, we can come and merge these, and if we right-click, we can go back to Polyline Column Editor, and you can see here that I've got now that wall profile. Now we've merged these walls into individual panels, and again, we can ask the program to automatically try and contain this for us. And you can see here it's automatically providing all the containment reinforcement around the corners. It will provide the detailing in here. If you want to add extra ties and so on in here, you can. It's entirely up to you. Okay, and you can use this for then design and detailing. It's up to you. If you don't want to do that, of course, you can just design them individually. The choice is yours as the designer. Now you'll see here that I've been creating a model and plan. At this point in time, I may want to just come and show you this in 3D. You can look at the view here of the model within 3D, and I can look at different views, and I can tier as many windows as I like to look at different parts of the model here. Okay. Now, at this point, I might want to come in and start to assign some other types of loads to the building. I'm going to put in some brick wall loading. So again, I can draw from a library, a little bit like the slabs, where we can set up different types of brickwork, and we can type in the height of that, and then that loading is automatically created on the beam. Now I can copy this loading, and we can replicate this easily around the edge of the building. So if I just copy this externally around this, if I right-click, we can then paste these to these other members, and you can see here that brick wall load is automatically set up. Now if I copy this again, okay, we also have the ability to be able to do what's called defined. So if you want to be very accurate with how your loads are assigned to the structure, you can be. I might want the brick wall just to go to the middle of that beam. Maybe I'd like this brick wall just to run down that beam to a certain location. So all of this you can see, and that can all be visualized in 3D here. I may have other types of loads that I want to assign. Perhaps I do have a wall load sitting on top of the slab. So again, we can just key in the properties here, okay, and we can come and define that in the model. So if I wanted to place a wall in directly on top of the slab, you can see these have also been created at the same time. Within a building, you'll have things like services and running around, and you may want to create and position different openings to cater for those. The beauty with working with a physical model is that they can easily be adapted. So if I pick this up, I can move this around, I can place this wherever I like. If you have other types of set downs, perhaps you've got a bathroom, or maybe you've got part of the building which is a little bit different, you can just come in and create this. So if I just decided that in here I wanted to create a drop in the slab, I can easily come and define that within the model. Last thing I'll touch on here is if I come to the walls here, similarly, if I right-click, we can come in and insert openings in here. Maybe I have a window. I could even put the value of glass in, depending on how accurate I want to be. All this can be considered within the model. So that just gives you an idea. I've just created a simple floor. At this point in time, I may want to take this, and I'm going to just come in and insert some floors. So let's just say this is a 5-story high building. Okay, and I'm going to take that floor and I'm going to come and generate this information up. So I'm going to copy that up a few stories there, and you'll see that this is just replicating up the building. Okay. Now once you've got this in, it's all editable. So if I want to make changes as I go, perhaps I'd like to remove those beams there, I can. Maybe I'd like to reconsider the structural system at the top here, and maybe I'd like to I'm just going to come in and grab all the beams. So if I just come in and use the filter button there, I can select all the beam members there at the roof, and I might get rid of those, and we might want to work with a flat slab. So you can see that I've just quickly changed that from a beam slab system into a flat plate. Okay, it's easy just to come and adapt and modify the model. Similarly, if I just grab these, if I just come and selected a few columns here. Okay, so you can come and select the elements. You could just box around and select. If I grab, say, whoops, some of these columns here, we can also come to member tables. And if I come and grab the tables there, perhaps I want to change these columns to say 400 and properties, and you can see that they've instantly changed and they've been adapted. So it's very easy just to edit the model, to just change it, to shape the building the way that you want to see things presented. At the roof here, I'm just going to touch on some of the new features that we've got with steel modelling. So when you come to create steel elements, you have libraries here of different sections, and there's a broad range of different sectional databases you can choose from. I may want to use a UC column, and I can just grab something that I might want to start with, and then we can place this within the model. Okay, so you can model in either 2D or, as I am doing here, position things in 3D, and you can see that those columns are quickly created. If at this point, maybe I want to come in and create some trusses. So again, I can just snap to points within the model, and you can then come and preview different truss shapes. So you can come and choose appropriate type of truss that you might want to work with. Okay, these can be aligned the way in which you like. You can easily come and adapt these. So if I want to have 4 bays each end, okay, or different truss configurations, I can. The members are grouped, so it then becomes easy to edit. So in this situation here, I've got diagonals there. Maybe I want to change these to tubular or square, or maybe channel sections, I can. If I want to use back-to-back angles, I can also do that. So it's easy just to come and adapt and make changes globally to those elements within those groups, and they're set. If I just remove the verticals there, this makes the placement of that easy. I can also set up splice positions as well for the connection design. So if I hit OK, that truss then is created. That then becomes available for me to use elsewhere. So I can easily grab this and copy this across the structure. I can then start to just work on this roof level. So I'm going to also place at the same time some beams. Let's just grab a beam section to start with, and then I can choose fixities and so on within the beam. I don't need to draw them one by one. We know that the columns are there. The beams will be automatically split as I draw these. Okay, and there you can see that those beams are created. Now you'll notice here that the snap points are dynamic, and you can snap to any part of the model that you like here. So I'm just going to come in and tie these frames together. Let's just tie these beams together at the top, frames together at the top, and they're done. I'm also going to place in this model my purlins. So let's just grab the 2 end bays here, and you can see here that it's proposed an arrangement for the purlins. Okay, it's set these up at nodal points, intersections with the truss. Okay, so it's trying to use some intelligence with how it does this. You can adapt this if you wish. What you might notice with this version is that we also can model the joists or the sag rods, and if you don't want to have these in, they can be removed. You can also assign loads to this. Okay, you can change member sizes if you want to use different sections in here. These can be adapted at starting point. And if you just hit OK, then that will be created in the model. Now, I can also click on elements. So if I wish to create between those 2 columns, I might want to come in and set up let me just do that again. Maybe I'd like to set up a brace. You can just choose these elements here, and then you can see that a brace is proposed for you. Now, there's different types of braces in here that you can choose from. You can just come and set this up to suit. Okay, so it could be a diagonal brace or maybe even a K-brace. It's up to you. Now, the bracing positions can be manipulated. If you wanted to move a brace by 500 or so on, you can see there that the analytical wire is kept where it is. If you don't want that, if you want it to align with the new position, that can easily be adapted here. Okay, if you want to make any adjustments here, these are dynamic, and you'll preview what we're going to create before we create it. So if hit OK, that can get built. You can model in different planes. I'm modeling in the frame of the plane of the roof there. We can easily come and create these. If you want to click on different elements here, these can be easily set up. Now I'm going to just finish this off. Let's just place my girts. And again, I can key in the spacings here. Okay, if I don't want to see sag rods, these can be turned off. And then if I hit OK, then my girts will be created here. Okay. And the last thing I'm going to do here, let's just place these external ones on this side as well. Okay, I could put the internal ones as well if that's what I'd like to do. So at this point in time, I'm just going to, let me just save the model and before we move on. Now, the important thing with what I've done here, and if you might just see there, is that the purlins are sitting directly on top of the truss. Okay, the girts are on the face of the column. The bracing's in the plane of the column. So what we're doing here is we're setting out things to suit the way that this may be constructed and fabricated. Now that's very important when working with ProtaStructure, because at the end of the day, what we want to create from this is detailed documentation, all the drawings and all the detailed design we want to drive from this physical model. So at this point in time, I'm going to now move into looking at the analysis and design. When we select the analysis button, you can see here that a range of codes is presented. In this release, we have introduced the American codes of practice. So you've got ACI code. There's also other codes of international codes available: British standards, Euro codes, Turkish standards, Hong Kong, Singapore, and there's other localizations in there that you can choose from. We've also done extensive work on the seismic side of codes. So we've introduced the IBC, UBC codes, together with local variations covering specific requirements for both Philippines and Indonesia. They have their own codes of practice, which are similar to the American codes, which we have fully incorporated as well. So you can choose your codes here: loadings codes, steel design, earthquake codes. All these are set, and then you can move into starting to define loading on the structure. So I'm going to look at the seismic parameters here for this building. Okay, in here I can come and choose my seismic zone. It could be zone 2. This is in the Philippines. Seismic sources can be identified. Okay, we can also come and choose occupational categories. This just follows the code. You'll just choose what type of structural system you're using. I might be using a dual system with a special moment resisting frame. Okay, I can also choose the type of frame. It might be composite steel and concrete, concentric based frames. Response coefficients, overstrength factors will all be assigned here. Okay, automatically will be done for you. Okay, you can also choose your soil types depending on where you are, and if it's a soft soil, you can see that this is adapting. The spectral curve will adapt to suit those soil profiles. Now, of course, if you have your own data, if you want to type it in, create it yourself, this can easily be done. Now, I can choose a number of modes I want to run. Dampening coefficients can be applied. Eccentricities are automatically worked out. We also do some quite sophisticated checks to check for irregularities. And now these can be very tedious if you have to do them by hand, but torsional irregularities and elevation irregularities are all checked by the software, and we will automatically make modifications to the analysis should these exist. In addition, we're also doing some very detailed seismic checks. So we will check for wall frame interaction, second order effects. We will check for strong column, weak beam, and we will also get into the detail of checking joint shears. Now, if you've done that, like I remember as a graduate engineer in New Zealand, it's a very tedious process and very time consuming to make sure all those bars fit. So we will perform all these checks automatically for you, and there'll be detailed documentation provided with that. We even go down to making sure that you're meeting minimum requirements to the code. So you're making sure that your minimum site member sizes are selected, and that you're not making any mistakes with the loadings process. So that's set up, that's applied. I'm now going to move in and also create my combinations at the same time. Pattern loading is automatically established here. You can also run stage construction analysis. We see a lot of tall buildings in Asia in particular, 50, 60, 70 story high buildings where elastic settlements or differential elastic settlements come into play. You can take advantage of stage construction analysis here. And I can also set up my lateral cases. So I'm going to run response spectrum analysis. I can choose what combinations I want to run. All the different variations can be run here. We can also run vertical earthquake. I'm just going to choose a few so that the analysis is a little bit more efficient. Now we also have introduced with this version the ability to use cracked and uncracked section properties. So for vertical combinations, I can use uncracked cases, and for lateral cases, I can use cracked. So we can run these concurrently. We will set up 2 separate stiffness matrices, and this then allows us to satisfy all the detailed, perhaps, considerations that you might want to make against the code for assessing different material properties within analyses runs. So if I hit OK, all the combinations will automatically be set up for me. These factors can be edited. You can make changes in here if you wish. Okay, if I hit OK, then they're done. Now, we also introduced automated wind loading in this version, so you can key in basic wind speeds. we will automatically populate different data into the geometrical data into this. You can choose different exposure categories, and roughness can be set up to suit. And this is following the American standard, but you also have British, Australian codes. We also have European standards in here as well. Okay, and we will then automatically work out the pressures as well as the loadings being applied. And they just get applied to the structure and they're automatically set up for you. Now you can customize material bars and grades to suit the way you want to deliver the project. So if I don't want to use certain bar sizes for certain elements, these can be customized. Okay, you can set up different grades of steel and concrete here just to suit the project. Okay, so all this is customizable, and you'll do this when you're getting a job established. Now the crack section properties are highlighted here. You can define different properties for both shell and frame shear walls. We have a new basement wall object which can have different crack section properties from shear walls. You can also, we've also introduced coupling beams, and you can also play with these properties if you wish. Okay. So if I hit OK, they're set up. Now I'm going to move into run this now, and I'm going to use rigid zones. I'm going to actually build out rigid arms within my beam column joints. I can also come in and choose to mesh my walls, and you can define different meshing parameters here. I can also come in here and choose to mesh different floors within this building. Now I had a flat slab at the roof there. This roof level, I'm going to choose to mesh that, and I can play with the parameters there, and the stiffness parameters, semi-rigid membrane and so on can be set up here. Now the analysis is just a button, okay, and at this point in time I can just hit go, and what we're doing now is that we are now going to take this model, this physical model, and we are automatically going to build the underlying intelligent analytical wire. So as I've been going, I can assign different fixities to members. I've set up my load combinations. The load distribution is automatically being performed. Okay, and then we can then move in and take this and build the analytical model. Okay, so within this version of the software, we've introduced a new 64-bit enhanced solver. Okay, and this allows us to run much larger projects much faster. And you'll just see this is just about to kick off, and we're now running through the analysis process now. So you can see here as it's progressing through different stages, these are all documented, so you can see how this is going. We will do checks, so you might realize when I did create this model, I actually have a column sitting on top of the slab. We'll interrogate the model, make sure that everything's okay, that there aren't any issues here, and then we will carry on with the design. It's now going through, it's prepared all the data. We've compressed this so that as you're building the model, this data preparation is happening concurrently, and we're now running the analysis. So as you can see here, it's going through the analysis. We have a couple of different solver options. You can use the sparse solver or the skyline solver. That's finished. And post-analysis, we're doing a series of checks to make sure that we satisfy the code. So you can see it's going through and checking different aspects of the structure to make sure that everything's okay. Post-analysis, there will be reports prepared to show whether they satisfy the code or not. Now I've done the analysis already. At this point in time, I'm now going to move in. It's now going to move in and run the design. You may see there it's moving in and quickly going through and designing all the columns and walls within the model. Okay, these are done in a batch process, so everything is streamlined. If there are changes that occur during the design process, we don't lose this information. So anything that you had designed before is kept, and later, if there were changes, maybe somebody missed a water tank or some loading off the structure, or perhaps some of the structural arrangements need to change. You don't need to start from scratch. You can run check designs in here, and we will then go back and automatically check the existing steel, existing reinforcement arrangements against those changes that have occurred. We're also doing all the checks as we run through here to satisfy the code. So in this situation that I have with this structure, we are looking at capacity design or ductile design. We will be looking at column overstrength checks. We will be looking at the joint shear checks. All these will be integral with the way in which we go about designing this building. Okay, so let's just finish off. It's just doing a few more elements here, and then I'll be able to get in and show you a bit of the design. Now, when we have run the analysis, underlying this, as I was mentioning earlier, that we are building an intelligent analysis wire, and I'm just going to show you this so you can understand, perhaps if you're familiar with using SAP or maybe STAD Pro or those other types of general analysis programs, this is the same kind of view that you can expect from within ProtaStructure. So if I look at the model here, you can see we've automatically, we can selectively choose what we want to mesh in the building, which is what I did, and I can come and choose to look at these different contours here. Okay, you can see contours, and you can start to look at different forces in the model. So if I wanted to look at, say, axial load, and I'd like to know how these loads are changing as I'm going up the building, this can easily be reviewed. Okay, you can filter out different parts of the model. If I just like to look at perhaps a particular floor, maybe it's story 2, and I want to look at that in a bit more detail, I can just highlight that, and maybe in here I'd like to look at the shear, or perhaps I'd like to look at the bending. All this can be interrogated within the model. Okay, I may even want to be looking at seismic load cases just by themselves, or as part of combinations. They can all be easily reviewed here, and we can interrogate these. Now, we do make use of rigid zones, and you'll see that we've actually built out rigid arms from the beam column joints here, and these allow us to look at more efficient design. Okay, we're more accurately looking at the stiffness of the beam column joints and frame interactions, and this will then lead to a more economical design and approach to your frames. So if I'm happy with that, we can then move in and look at the design of the structure here. I can just click on a column, and we can look at detailed checks for this column. It will highlight to you what is critical. In this case, it's actually just a gravity case. We can look at interaction diagrams, so we can see capacity plots here. Okay, axial limits, seismic limits, and so on will be specified, and you can see the interaction diagrams. You can also look in detail. We will iterate to work out the neutral axis. We'll work out the most efficient way in which the structure can be designed, and that will all be documented. Similarly with our beams, if I just click on a beam, okay, we can just come in and look at this in more detail. Okay, and we can look at the arrangements here. We will automatically select the arrangements. You can look at diagrams here. Okay, what we have done with this release is that there's these new diagrams which are dynamic, and you can see I'm looking here at the shear force and bending moment diagrams. If I'd like to look in more detail, let's say my deflection plots, okay, I can. These are the envelopes. If I wanted to look at dead load cases, or perhaps my seismic cases, or perhaps different combinations, you can just easily navigate through these, and these will adjust. And obviously we're then enveloping these for the design. Now with the new enveloping, this provides for much faster grouping design, as well as general enveloping. It also allows us to interrogate diagrams much more closely. An example of that, maybe I want to look at the torsional forces along that member, I can just highlight that, and we can come and have a look at those in more detail if we wish. Okay. Now, you might also notice there's intelligent design stations there, and they are useful when we get into looking at other aspects of design. Now, if I make changes here, you might see that instantly we're checking this. So when I make that change, the design's live, and things here will adapt accordingly. Okay, that wasn't adequate, didn't pass the code, and I made that adjustment, and then that's okay. So all my beams in this structure are designed. Similarly, I can come up to look at the steel work, and we can choose steel elements here. We can go to steel member design. Okay, I can, if I just ask it to check, I didn't go through and design all the steels in one go just before, but I can perform the checks here. Okay, you can look at detailed checks here of all the members, bending, tension, shear, all the classifications will be done. And again, we can look at the diagrams for that member. Now, those design stations I was talking about are very important for steel work. We will intelligently track the bending moment diagrams in this release, and we will work out effective lengths automatically for checks such as lateral torsional buckling. Okay. Now, the these checks can be for say a beam. They could be, in this example, maybe it's for purlins. Now again, they're all grouped, and you can come and look at the design checks for these. Again, you can look at combined checks, tension checks, and so on. They're all clearly documented here. And again, you can interrogate the diagrams like I did earlier if you wish. Similarly with things like trusses, again, you can come and interrogate these. Okay, we will check them. So if I want to check the chords, okay, we are calculating automatically the effective lengths, and we're also looking at the length that chord might be in compression for the effective length calculations. All this is automatically done by the software. We've got a degree of intelligence here in how we're performing the design. Now I've done the main superstructure. I may just want to, at this point, just move down to look at the foundations. So if I just grab these, and I'm going to, at this point, just come and insert some foundations. I'm going to work with some pile caps, and in here I can then move in and start to look at the foundation design. So with this release, we've done a lot of work on enhancing the foundations. You can put in the allowable working load. If you hit OK, we can then batch design these, and then all in one go, our pile caps are designed. Now we can group these. It will find pile caps which are similar in size and similar in number, and if we hit OK, then those groups will be set up here. Okay, now if we do select a particular pile cap, okay, if we want to look at this in more detail, we can interrogate this more closely. Okay, and we can see the pile cap here. These locations are all editable, so if I find on site that piles may have moved out of position from what was originally proposed, we can key in those new positions, and we will instantly check this to make sure that this is okay. And we can then produce the as-built for those pile groups. I might just run around and just show you a couple more foundation types before we start to get into looking at the documentation. Okay, I'm going to key in a thickness for my pad bases. These are automatically designed. You can choose square footings. These can also be slightly eccentric, so you can play with things. If things are close to the boundary, then they can easily be set up here. Okay. Similarly, I may want to introduce a raft, or maybe I'd like to in here place beams. Okay, I can just key in. Maybe I'd like to put in a strip footing. So we do that just by placing a beam in here, and we can insert strip footings. These can be slightly eccentric if you wish, and then we can take these and we can design them. So the software will take all the loadings automatically from the analysis results, and then these can be designed in here. Okay, so if we hit OK, they'll be set up, and you can see there that quickly I've just come in and not just created the pile caps, but also I've created a strip footing. I've also set up and created a pad base there. Now, there's other types of foundation systems that you can employ in the model. I'm not going to go into these in too much detail in this presentation. We do have other presentations that are going to follow this, which will focus on particular topics. But if I wish to put in a raft in the model, or maybe I want to insert a pile raft, these can easily be defined. And you can set these up to suit what it is that you're wanting to consider within the project. Okay, so I'm going to maybe for this, I'll just show you how pile rafts work. You can choose an arrangement, and then the piles will be built into the raft here. Okay, these are editable. If you do decide that you wish to make changes as you go here, these can be adapted. Okay, the piles also have individual properties, and these can be relocated and moved. Sizes and properties can be adapted to suit the project that you're working on. Okay, so this gives you an idea about the basics of ProtaStructure. I'm going to, at this point, I'm going to just summarize where we're at with ProtaStructure, and I'm just going to just give you some background on what's new or what's been introduced with this release. Obviously, I mentioned that we've got the new American codes that have come in, and this is a very comprehensive implementation of the American standards, both in terms of design as well as in terms of seismic design and detailing as well. And we've also introduced localizations to suit particular markets, especially in the Philippines and Indonesia, where they have their own standards. Turkish standards have also gone through a comprehensive upgrade recently. It's probably now the leading or the newest seismic code available globally, and that's also been fully incorporated with this release. For those users in Malaysia, we have also updated the Eurocode 8 to incorporate the latest Malaysian National Annex. We have introduced the wind loading, as I showed you, and this covers a range of codes. We've also introduced this new diagrams where you can see very clearly all the results, and they're adaptable. You can choose what you want to view. You can look at displacements, different values, and these are also enveloped for design. Steel design, as I mentioned, has been enhanced. We're now looking at design stations. So if you have members framing into different positions, we will automatically work out the effective lengths for you, and detail checks will be performed. Now we'll look out for auto design and design grouping, which is on the roadmap. You'll start to see that coming through in subsequent updates. We also, especially for basement wall considerations, we've introduced a new element for basement walls. When you do use this, they'll automatically be meshed, and we will, moving forward, be providing special detailing design provisions for these. Coupling beams have also been introduced. These are very important for use in seismic zones to tie wall frame together. We will look at the interaction of these, and we will also look at the design and detailing of these accordingly. For steelwork, we've introduced the sag rods to give you more efficient design with dealing with purlins and girts and the like. We're also inserting multiple braces into columns, trusses, columns, beams, top and bottom chords, wherever you like. These can easily be set up now. I did mention that cracked and uncracked section modifiers can be provided, and these can be easily established within the model, and we will run 2 separate analysis runs to cater for the different section properties. For advanced seismic, we are considering basement structures as well, and for basement structures, in accordance with the code, you have to do 2 runs, one with and without masses from either the superstructure or the basement, and these are automatically done in one single run within the software. Generally speaking, most programs out there, you might have to set up 6 or 7 models to consider this. We've also enhanced the solver, so we have new 64-bit solver, and this tackles very large projects, which we're seeing much more quickly and robustly than we have in the past. So I've come to the point now where I want to start to look at my documentation, and to do that, I'm going to come in and load ProtaDetails, and you'll just see here that I'm taking this project now, and I'm going to push this into ProtaDetails to start to document the design. So it's just opening up here. Everything I'm showing you today is live. There's no smoke and mirrors, so I'm just taking you through exactly how the system works to try and cover the basics, but also cover some of the new features. When we come in here, the way ProtaDetails works is that we will just come in and automatically generate information for you. So all the layers and line types you can establish within ProtaStructure. It's fully flexible. You can then come in and choose what you want to draw. So I can choose exactly how I want to draw. I'm going to insert these to a sheet. Okay, I will come here and you can load your own title blocks. They can be your standard company title blocks here that can come in. You can choose how these title blocks are referenced, because we're also getting involved with drawing management here. So we will lay your references into the sheets in accordance with what you wish to have. You can play with scales. You can also choose in terms of how you would like sort of certain detailing to be done, truncation, for example, for the beams. All this can be set up in here. And you can then, once you're happy, you can then ask the program to come away and start to create this documentation. So what the system's doing now is it's automatically taking all that information that design information that we created in ProtaStructure, and now starting to lay it out into our sheets. Okay, and it's systematically looking at how it can go about optimizing the organization or the details into your title blocks, and it's now going to move in and start to arrange these for you. Okay, so you just see here it's just starting to produce, and you can see there is the outline of a title block. Okay, and you'll see now it's just going to start to create this for you. Now, while I'm talking, ProtaDetails is a complete CAD system, so you can make full perform full drafting within CAD. You might just see up in the top corner there that this is actually a DWG file. We're working natively in DWG format. You can make changes to this. You can use it as a complete CAD system if that's what you want to do. Now I've finished and I've produced my drawings, and if I just zoom out, you can see that everything's just been created in one shot. So all the drawings, all the details that we wanted to create have been automatically arranged into our sheets, okay? And we can then come in and interrogate these in a bit more detail. So if I want to see my foundation plans, if I'd like to see my key plans here, you can see the positioning of openings and drops there. Okay, if I'd like to come and look at set out drawings, you can come and view these. Notice that these are all laid out into your sheets, so they'll be exactly in your sheets and exactly detailed the way that you would like them to be produced. Okay. If you want to look at elevations of the walls, and you'll notice with this release we also are detailing around the openings for walls. You can also come and look at the column detailing as well. And notice that the containment zones and so on for seismic detailing all automatically being detailed in accordance with code. Okay, and you can see very clearly how these would go about being constructed. Now, traditionally, in some of our markets, people prefer schedules, and these can be created as well. And you can see there that even for the schedules, we will automatically look at the details and we will group members where we can. Okay. Now, if I come down to the beams here, you'll notice that, again, all the containment detailing is being done, and you can see how that's being prepared. You can also look at the bars there. Okay, if you just do look at a bar there, you can see that this is positional mark number 7. And if I come over to the side here, you'll notice for this bar here, these are actually 20s. There's 9 of them. They're 9.4 meters long, 84.6 meters in total. And you can see the bar bending shapes there. You can also see the full quantity takeoff. Okay, so all of this is produced automatically from the model. Now, there are other ways of presenting information. If you want to see things in a tabular form before you actually start to prepare detailed drawings, maybe you're just going for tender and you just want to provide this preliminary information, that's also available to you. You are in CAD, so anything in here is adaptable. So if I decide that I want to move a detail around and reposition it, okay, or perhaps I decide that maybe I want to actually come in and crop a beam, okay, and I want to just cut it and reposition it to suit placement. All this can be done within the software. Okay, so in here you have full CAD capabilities as well. So if we come down to the foundations, you can see the pad footings, the strip footings, pile cap details are all being produced here. Okay. Now, so ProtaDetails, the idea around ProtaDetails is to lay out everything into your sheets. You can work within ProtaDetails to lay out to specifically what you want to see. So if I decided that in particular I want to look at an elevation of either a single column, or maybe I'd like to see the entire elevation up the building, I can come and draw that. We've introduced precision detailing, so we understand where shapes are changing and the bars will adapt to suit. Okay, you can just selectively choose from the table here what you want to draw and create. So I can just pick certain members and draw them out, okay, within the model. Okay, if I can also within here create and draw my own details. So if I want to use this as a CAD platform and come in here and insert things like bars and the like, I can. And these can be easily positioned within the model. Okay, cover and so on, and all that can be specified, and we can use this to quickly create details of our own. Now, if I decide that maybe for this detail here, this is a variation on the project, and I want to provide complete quantities takeoff, instantly we can adapt and calculate that for you. So if you were wanting to put in a claim for a variation on the project, then that can be done. Now, in addition to this, we also have a comprehensive library of component design. I'm not going to have time to go through this in detail today, but if you're wanting to design things quickly, things like stairs and so on, in here you can specify loadings. We can design these, and then we will then produce the drawings for you. Okay, so all the documentation will be prepared, and all the design calculations will be done. Check out our new pile design. This allows you to feed in all the geotechnical properties, and we will calculate the working load as well as perform lateral analysis of the piles. We've also introduced new engineering utilities library in here, where if you're wanting to know certain things like, say, for a certain bar size to a certain code, what's the bending length, extension length, hook length, area rebar calculators, anchorage length calculators. There's even uniform flow depth calculations and so on in here that you can take advantage of. But primarily we have this comprehensive library of calculations that you can use. We also have a detailed library of calculations here, and we've introduced things like a new beam detail capabilities, where you can come in and if you just wanted to quickly add a few extra spans to a beam and you wanted to come and adapt these to suit, you can play with things like dimensions in here. If you just want to quickly use this to draft elements within the structure, we can come in and place that, and then you can use this as a drafting tool. So the idea behind Proto Details is both a design library as well as having a comprehensive detail library. So I'm going to stop there, and I'm just going to come back and just summarize where we are with Proto Details. So with the 2019 version, we're creating everything in one click. So all the details will automatically be prepared from ProtaStructure and documented in full. And that comes schedules, beam elevations, tables, right down to the foundations will all be automatically generated to your preferred drafting standard. You can also enhance drawings. We've introduced slab sections with rebar in this release, and you can also add other details to drawings as you go. So it's all very flexible. We've done a lot of work on enhancing the way in which we go about detailing. So things like openings, column sections which changes in size, even sloping elements, beams and columns have all been enhanced significantly over previous releases to give you a much more precise detail with less editing required. Ductile wall design and detailing is very, very powerful, and we will go about detailing this out to suit the seismic provisions and codes. There are new detailing options where you you want to crank bars into end zones to give you a better detail. That can also be performed, and we will design the walls based on bending envelopes for seismic. Similarly with the column ductile design, you can produce laps at mid height. Okay, we will check for beam column joint shear checks. When bars come up and they can't continue, they'll automatically be curtailed, whereas bars that can continue will be automatically cranked. So it's smart, intelligent ways of producing details that we will perform, and you can see all the ductile detailing requirements here for that tapering column. The component design library is continuing to develop and evolve. We've done a lot of work on the reinforced concrete retaining wall with this release. You have stairs, corbels, pile design. There's even engineering utilities available now that you can all take advantage of within ProtaDetails. We've also been adding component detailing. So if you're just wanting to do quick drafting, quickly create elements for beams, foundations, maybe you've got lift pits, corbels, maybe you've got culverts that you need to do, all of these can be easily drafted very quickly within ProtaDetails without you having to manually create those information. And just to highlight, within ProtaDetails, we are working with CAD objects, and you can create your own details in here quickly. Polylines can be converted into rebar, so it's very intuitive and intelligent. We can quantify everything that you create within here, so if you're having to assess variations in the light, that can be done. And we've introduced quite systematic and quite comprehensive undo and redo features that covers not just basic CAD entities, but also the intelligent objects that we create within ProtaDetails. Now, all of this can be sent out to your other preferred CAD platforms. So if you're working with AutoCAD or ZWCAD or a range of different other CAD tools, we can automatically provide and populate all the details out to those systems. So last thing I'm going to touch on today is Proto Steel. Once we've moved in and done the steel design, I'm now going to launch Proto Steel, and I'm going to take this model out into a Proto Steel platform. So the idea is that we've already done our design within ProtaStructure, and we're now moving it into Proto Steel to perform the steel design. Okay, so we're back in. Okay, I'm just going to quickly go in, and I just want to finish off the documentation of this. So to do that, I'm just going to let's just work with a few joints here. So previously, you saw that I designed this. Okay, I'm also going to, at this point, maybe I'll also assign those purling connections again. Let's just quickly come in and create those. Okay, I'm at the same time going to use IntelliConnect just to look at the design of this truss. So if I just select these elements, okay, I can come into IntelliConnect, and I'm going to ask it to also systematically come in and design the truss joints there. So that's going through now and quickly creating those. Okay, you can see it's just moving across the truss there to create those joints. Okay, and then it will be done. Okay, so they're done. Okay, and again, I can have a look at the model here. We can interrogate this, so you can see some of the truss connections that we've made there as well. We've introduced other macros that cover things that are a little bit more complicated. So if I have a connection at the top there, that's not the easiest connection in the world to make. Okay, and we can come in and set up more unusual macros. Again, these can be edited, so I may just want to tweak the arrangements here. Okay, maybe I want to play with the way in which they're set. So if I just apply that, you'll see I've just made some adjustments there. Maybe I want to make that a bit longer. Okay, maybe make that say 5. Okay. So these can just be you can just apply these and set these up to suit. Okay, and you can see that they're done. Now at this point in time, I want to move in to create my documentation. So in Proto Steel, we can come and select a joint, and we can apply what's called a detail manager to this joint. So I can call it this one, say truss 1. We can add this, and then we can choose objects that we might want to include within the detail here. So if I just right click, you'll see that there's a box created around this joint. Okay, now think of this a little bit like a camera. So I'm going to take different photos of this joint. I may want to look at it end on. Maybe I'd like to look at it from the top downwards, and perhaps I'd like to look at it from the face looking forwards. You can even add a 3D view in here to look at different views through the joint. Now, once we've done this, we can actually come in and slice and dice the model however we like. So I'm going to create some views through the model. I'm going to choose to just create a quick view of this truss at that elevation, and you can see all the details here of that truss. What I'm now going to move into my drawings, and I'm going to go to my drawing manager. Okay, and I'm going to create a new drawing. Let's just call this truss. And if I hit OK, you'll notice that those views were populated here, and I can bring these into the model, so you can see the view of that truss is provided here. Okay, and you can see the elevation there. These can all be, you can then start to annotate this. So if I would like to maybe at this point come in and add some dimensions to this truss, okay, these can be dimensioned up, okay, and we can create. At the same time, you can see that that box that we created around the joint is also highlighting that connection there. And if we just click on this toolbar, same box at the top here, that then gets drawn out. So here we can see that all this connection is then documented out from the views that we've created. Now these labels are dynamic, and you can move these around to reposition things. Perhaps you don't want it to clash with how you'd like your detailing to be done. Okay, all these labels are dynamic, and you can just reposition them within the model. I could do some further annotation here. Perhaps I'd like to, at this point, do some, let's just maybe provide some dimensioning. Okay, so I can just annotate this up to suit the way in which I'd like the connection to be designed in detail. So that's the idea with ProtaStructure. Using IntelliConnect, we can create, we can connect the entire building together, and we can then produce all of our engineering drawings from here. By creating a fully connected model, at the same time, we're also able to completely produce shop detailing as well. Okay, so that kind of gives you an idea of how ProtaStructure works and how the system works together to create one combined model. Just to summarise at this point then, within Proto Steel, is that with the 2019 version of Proto Steel, we've introduced IntelliConnect. It will automatically analyse all the joints within your structure, and it will try to make intelligent constructible connections work. Okay, you can. It does cover a broad range of different connection types, so it's just not purlins and so on. Beam joints, truss connections, simple, melded, splice joints will all be automatically designed. We can also add additional steelwork to complete the model. So if I wanted to introduce things like railings, stair rails, staircases, those types of additional steelwork can be added into the Proto Steel model and all documented. You can set this up and customize it to suit your local company standards. So if you have for certain sections a certain type of detail that you'd like to use, whether it's pinned or fixed, or maybe you've got certain preferences for the number of bolts for certain types of connections, these can all be customized and standardized, and then you can apply those within Proto Steel to get the type of detailing that you wish to have for certain types of projects. All the documentation is produced, so very clearly you can see all the underlying checks in accordance with the code, and clause by clause code checking. We are progressively adding all the macros in there. We are progressively creating all the design documentation for, and you'll see progressively that list of full connection design being extended progressively during the course of this year. Obviously, we're then creating all the detailed design, a detailed drawing output, and you can see those and prepare them in different ways: plans, elevations, sections through connections, even 3D views can be created. And we also can go down to fabrication detailing. So if you want to see how components of those are detailed out, that can be easily done within the platform. Now, if you want to share information from Proto Steel, we will send information out natively to systems like Tekla, Revit, Allplan. Okay, when you do send out to a system like Tekla, it's native, and it automatically link to macro objects that they have. Okay, but we expect that you really like Proto Steel, and you can use Proto Steel fully by itself to produce all your steelwork detailing, right from engineering drawings through to shop drawings. Final thing I'm going to touch on is how we communicate with other BIM platforms. And to do that, I'm just going to touch on a little presentation which may nicely summarize things today. What we've done earlier is work with physical objects to develop a model, and I've done that very quickly, and we've then designed that to our chosen codes of practice. Now, once we've created that model, we can then move to document that, and we have two platforms: Proto Details for the concrete work and drafting, and that works natively in DWG and lays everything into your sheets. We also have Proto Steel for your steelwork detailing and connection design. Now, because we're working with physical objects, we can easily communicate these into other platforms. So if I'd like to share this with Revit or other BIM-related platforms, we have bidirectional integration with Revit. We can take models back and forward. All the physical information is shared: openings, drops, unusual layouts, all the offsets, everything will be automatically communicated directly into Revit. You can make changes in Revit. Maybe you're getting together with the project team and coordinating the project. That changes can be made, and these can be communicated back into ProtaStructure. And you can perform this as many times as you like. Now, we do link with other platforms, so we have IFC links out to systems like ArchiCAD or Allplan. We also can natively link with Tekla structures and ProSteel, and we can also create all of our NC files for fabrication detailing. And so this is where we pass data into the actual manufacturing process. And we're very open, so if you want to communicate models to other platforms like analysis platforms like ETABS or SAP, LUSAS, SAFE, all these can be easily done. Okay, we can also document other things in other ways. So if I want to create 3D DXF information, calculations, all these can be generated automatically from the model. All the documentation for submission, detailed calculation reports and so on is provided within the platform. So that gives you the overall view of how the ProtaStructural BIM system works, with a particular emphasis there on how we communicate with other BIM platforms. So just to conclude, I hope you like what you have seen today. Obviously, I've gone through a lot of information very quickly and tried to cover as much ground I can in the short time that we have today. We are continuing to invest significantly in new development work, and the 2019 version is a step in the vision, a big step in the vision that we have for the software. We are actively working, have very big development teams actively working on new technology at present, which we're going to continue to deliver over the course of of what is going to be an exciting period over the next years to come. For those of you who are interested in the system, we do have some very special pricing with the introduction of the 2019 suite. This is backed with free e-learning and training, as well as direct technical support in the first year. And if you are interested in that and you'd like to know more, please take a note of these email addresses. It's globalsales@protasoftware.com. For everywhere else in the world except for Asia Pacific, where it's asiasales@protasoftware.com. Okay, so if you are in India or East or China down to where I'm from, New Zealand, you're in the Asia Pacific region, and please drop us an email at asiasales@protasoftware.com. You also are welcome to visit our website and request any additional information from there. This is one event in a series of events that we've actually got planned for this year, and we do have another more detailed presentation on Proto Steel coming up very shortly. In fact, it's next week on the 17th, and that will be prepared by our tech, who is the general manager for the development of Proto Steel. I'm sure he'll do a much better job than I did today, and he'll be able to take you through some of the real fantastic functionality that we've been delivering with the Proto Steel update this year, and I'm sure he'll do much more justice to IntelliConnect and a lot of the very fantastic functionality that we have with that version. So please stay tuned. We really look forward to providing you with more information on this fantastic platform. Obviously, as you exit, we'd also like to know what you think of today, and I'd love to get your feedback. And if you are an existing user and there's things that you'd just really love to see in the platform moving forward, please also make a note. We'd love to be able to incorporate that. So that information again, if you are wanting to get further information, please reach out to contact us. We'd love to hear from you, and we'd really like, for those of you who are not using the Proto platform, we'd love to invite you as users of the system to join the many thousands of engineers that we have benefiting from the technology. Finally, but not least, I'd really like to just on behalf of our fantastic Proto development team, just say thank you very much for tuning in today. It's really wonderful to be able to present to you some of the technology that we've been involved with developing over the last year, and we look forward to delivering more and better new functionality in the many years to come. So thank you for today.